we are talking about percentage, fractions, decimals, and percent. We're going to be looking at the introduction to this topic. We're going to be looking at short division, how to use short division to convert fractions to decimals, how to express decimals as fractions, how to multiply fractions by 100 in order to convert them to percentages, how to express percentages as fractions to the lowest term, how to express percentages as decimals, and expressing decimals as percentages. Do not be scared. All these are simple concepts that deals with multiplication and division. That is all. You'll be surprised. All these, we've laid the foundation for all of this in weeks 3 and 4. So just basically division and multiplication. So let's go. So let's look at the introduction to decimals, fractions, and percentages. It's so easy in the sense that all we need to do is understand that when we were much younger, probably in play school, nursery, we counted in O's 1, 2, 3, 4. But our teachers then never told us that there's something between 0 and 1. You were never told that there's something between 1 and 2. As a matter of fact, there's a whole lot of things between 1 and 2. Exactly. There's a whole lot. That's why what life is all about. We'll learn in part, we know in part. All through life, you'll be learning something new. You'll be learning a whole lot of things. Life doesn't go in discrete values. It's not 1 and 2. There's a whole lot in between. Okay, so whatever you know today, whatever you think you know today, it doesn't end there. Okay, there's always something you need to know in addition to what you know today. There's nothing like perfect knowledge. Let's move on. So that's what we are talking about. Fractions. That's what fractions brings to you now. Fractions makes you understand that nothing is ever in discrete values. Everything is always in shades of gray and things like that. There's no absolute black and white. So let's move on. Good. I'm not trying to be philosophical here. So let's move on. Quickly, fractions can actually be converted to decimals, and decimals can be converted to fractions. Fractions can be converted to percentages. Percentages can be converted to fractions. And everything we've talked about so far basically is coming up after this slide. So now, first one, let's convert fractions to decimals. So what do we do? Short division. Remember, I told you everything in this week is a build up on weeks 3 and 4. So we've done short division before. Look at it. So how many 5 do we get in 18? How many 5 in 18? You all know that's the 3, isn't it? And there's a remainder of 3. This time we are not going to write out 3. We are going to put our 3 up above. But can we divide 5? Can we find how many 5 in 3? No. So let's add a 0 to that 3 and make it 30. But the moment you add a 0, you need to introduce your decimal point because you're now working in fractions of a whole. So how many 5 in 30? And that's a 6. And that's how it's done. If you do not understand, play it again. And we are going to employ the same strategy in example 2. So let's go. Example 2. Now, question. How many 8 in 3? It's not possible. Put a 0. Add a 0 to your 3. The moment you add a 0 to your question, always add a decimal point. Question now. How many 8 in 30? That's definitely a 3. 8 times 3 is 24. That means your remainder is a 6. Add a 0 again. This time we don't need to add a decimal point. We only add a decimal point once. So question 8 in 60. And that is 7. 56. 8 times 7, 56. I know there's a remainder of 4. Of course, you had a 0 again. 8 in 40. And that's a 5. Final answer 0.375. You can go back and watch again. Let's move on. Otherwise, you ask me questions in class. Okay, so let's go. I don't want this video to be exceptionally too long. Okay, it's kind of very for you when it is. Let's move on. 3/11. Now, this is a problem that I love to teach because it creates a scenario that is not as conventional as the previous two. So let's go. So how many 11 can I get in 3? Definitely 11 is bigger than 3. That's a no-no. 0. You know the drill. You had a 0. So how many 11 can I get in 30? So the one you add is 0, you add the decimal point definitely. 0 in 30 is 2. 11 times 2 is 22. And there's a remainder of 8. Remainder of 8. You had a 0, of course, but no more decimal points because it's not the first 0 you are adding. So how many 11 in 80s? That's 7, 77. Remainder 3. You had a 0 again. How many 11 in 30? You still get a 2. 22. 30 minus 22 is 8. You add a 0 again. How many is 11 in 80? That's a 7. Remainder 3. So 7. It will go on forever. You just have to stop at this point, okay? You just have to stop at this point. Usually you stop at 3dp, but if you want to answer in 3dp, what do I mean by 3dp? Let's show you. So this is your decimal point. This is your first digit after the decimal point. We call this 1dp. This is your second digit after your decimal point. You call it 2dp. This is your third digit after the decimal point. You call this what? 3dp. And this is your fourth digit after the decimal point. We call it 4dp. I'm not going to require you to give me answers in 4dp. Definitely not. So what do? We want our answer in 3dp or 2. So if I want my answer in 3dp, you recognize that this is 3dp. So you look to your right. What do you see? 7. What will 7 do to your 2? Aha. You know what 7 will do to your 2? It will add 1. So 0.273. And we are done. We are done with this. So we've successfully converted fractions to decimals. Let's move. So now we want to convert decimals to fractions. Wow. And this here is where we need to work. So let's go. So 0.75. Ask yourself, what are the significant figures? Ignore the 0 points, okay? So let's just write 75. 75 are what? How many digits are there after the decimal point? How many digits are there after the decimal point? Is it not 2 digits? The 7 and the 5? So add 2 zeros here, for God's sake. And make it a 1 beside it. So 0.75 is actually 75 over 100. It's actually 75 over 100. Okay, what did I do? I wrote the significant figures, okay? Pay attention. I wrote the significant figures. I ignored the 0 point, okay? If this were a 2 or a 1 or a 3, aha, I'm going to be writing 375. If this 0 were a 3, I'm going to be writing 375. But this is not a 3. We don't start numbers with zeros. You know that, right? So writing 075 is the same thing as writing 75. So that's why I wrote 75. So 75 over 100. Where did this 100 come from? Mr. Robot, you're a cheat. No, I'm not a cheat. It's maths. So let me explain it to you. So look at this. These are decimal points. This here is your first digit after your decimal point. It's called 1dp. This here is your second digit after your decimal point. It's called 2dp. That's why I'm adding the 2 zeros. These numbers is in 2 decimal places. That's why I'm adding the 2 zeros to represent it. So that's where it comes from. Okay, now let's move on. But this is not the lowest term. We can break this down. 75 by 100, we can actually break it down. So you know we can divide this by, let's say, 5. By the time you're done dividing 75 by 5, you definitely get to 15. I assure you that you get to 15. By the time you're done dividing 100 by 5, you get to 20. Okay, I'm not going to go into that anymore. You should know how that is done. By the time you divide 15 by 5, you get a 3. And by the time you're done dividing 20 by 5, you get a 4. You keep dividing until there's nothing to use anymore. We can't divide. 3 and 4 have no common factors. They have nothing in common. So they have nothing to divide with. So we leave our answer as that. That's the answer. 0.75 is actually 3 over 4. So let's look at this. 0.123. 0.123. So what does that tell us? Definitely is 123. 123 over what? Is it over 10? Over 100? Over 1000? Definitely there are 3 digits after a decimal point. We are going to need 3 zeros. 3 digits after decimal point, you are going to need 3 zeros. So it's over 1000. So what can we use to cut? I do not think there's anything that is common to 1 to 3 and 1000. The 3 can actually cut 1 to 3, but 1000 cannot. So I don't think that's possible. Uh, 4 can cut 1000, but definitely 4 cannot cut 1 to 3. 5 can cut 1000, but 5 cannot cut 1 to 3. So I don't think there's anything in common, so we leave our answer like that. Okay. So if there's nothing in common, you just leave your answer. This way, you don't need to simplify further. Let's go. Now we are done with fractions and decimals. Let's look at fractions and percentages. Wow, I love this one. 3 over 5 converting to percentage essentially is you multiplying by 100. Okay, multiplying fractions by 100 converts them to percentages. So 3 over 5 times 100 over 1. So we begin to cut. So what do you mean by cutting? I'll show you now. So we say 5 here, 1. 5 in 10 is a 2. 5 in 0 is a 0. So in that case, you are left with what? 3 times 20 above. Remember, when you cut, you only cut between up and down, numerator and denominator. You do not cut denominator and denominator or numerator and numerator. No. You multiply numerator and numerator, multiply denominator and denominator, or you cut numerator and denominator. Okay? So it's like people downstairs are fighting with people upstairs. So that's the kind of thing. Because I've seen it several times, lenders open to use denominator to cut the denominator. No, it's always in such a manner that the people downstairs always fight with the people living upstairs. People downstairs don't fight with each other, they complement each other. That's why they multiply. And the people upstairs don't ever fight each other, they complement each other. That's why they also multiply like this. See what I'm talking to you about? There's a 3 upstairs here, there's a 20 upstairs here. See, they complement each other, they multiply out. There's a 1 downstairs here, there's a 1 downstairs here, they multiply out, isn't it? But the people upstairs and downstairs fight. 5 was fighting with 100. At the end of it all, 5 got wounded and turned to 1. 100 got wounded and turned to 20, because 5 in 100 is 20. So you can see how that works out. Please never cut this way, never cut this way. You multiply it this way, you multiply it this way, but you cut up and down. Okay, you cut up and down. Thank you very much. Let's move on. So at this point, our final answer is 60 over 1, which is actually 60%. 60%. Pardon me, I'm just trying to write a percentage sign and it's just not ready to budge. 60%. Okay, good. So I got that covered. Now, the next thing I want you to look at is 3 over 8. Wow, I love this question. It's just so all encompassing. It teaches you everything you need to know about this strategy. So multiply by 100. So the first thing you need to ask yourself is, does any number at the denominator have anything common to a number at the denominator? Yes. We can actually use 4 to divide 8 and 100. So let's go. 4 in 8 is 2. 4 in 10 is 2. We made that 2. And then 4 in 20 is 5. So at the end of it all, we are ending up with So that's it. So now what do we do? How many 2 in 7? Do you know? That's 3. There's a remainder of 1. So how many 2 in 15? That's 7. There's a remainder of 1 still. 2 in 1 is not possible, so we add a 0 and then we add a decimal point. So how many 2 in 10? That's a 2. Sorry, that's a 5. Pardon me. That's definitely a 5. 2 in 10 is definitely a 5. Then you put your percentage sign beside your answer. So that's the 7.5%. Okay, so final question. Okay, 3 over 11, same thing. Remember 3 over 11? It's back here again. So what do we do? Now, there are questions that come like this that they are meant to stress you out. Okay, I wish you would not be stressed. Please do not ever stress yourself out. Okay, it's very very simple working with numbers like this. Okay, so what do I mean? What do I mean by it's simple? Okay, pay attention. Can 11 divide any number at the numerator? No. Is it 11? Does it have any common factor to any number at the numerator? No. So all you need to do is just multiply out your numerator 300. Multiply out your numerator, you get 300. Then over 1 times 11, that's 11. So all you need to do is find out how many 11 in 300. So the first thing you need to do is 11 in 300. Okay, so how many 11 in 30? So let's change the pen color. So how many 11 in 30? That's definitely a 2. 22, isn't it? We made that what? 8. How many 11 in 80? That's definitely what? A 7. We made that what? 3. Remember we've used this number before and we're back there again. So you had it to your remainder of 3, you had 0 because 11 cannot go in 3. So how many 11 in 30? But before you do that, at the moment you had the first 0, you had the decimal point. So how many 11 in 30 now? That's another 2. Remainder 8. How many 11 in 8? Not possible. Add the 0 again. How many 11 in 80? That's 7. Just stop there. Just stop there. Just stop there and round your answer up to 1 dp. That gives you what? 27.3%. Final answer 1 dp, 27.3%. That's all. 27.3%. And this strategy is quite very simple, but you will not learn everything in a day, definitely. We're going to be working through it in a week, and it will take some getting used to. It will take some getting used to. No way. So let's move on. So the next one is expressing percentages as fractions to the lowest term. Remember 75% we talked about? Uh-huh. So, okay, so 100, 15 over 20 divided by 5, and then you divide by 5 again, you get 3 over 4. Second example, 63%, 63 over 100. Now look at it. Is there anything that can divide these two? I do not think so. There's nothing that can divide these two, so that's your final answer. Then we move on now, expressing percentages as decimals. Expressing percentages as decimals. Okay, so let's go. 75 over 100, definitely. 75% is 75 over 100, and 75 over 100 definitely is you, you introduce a decimal point, that's 75.0. Remember that I told you that 5 and 5.0 means the same thing. Remember that? Yes. 6 and 6.0 mean the same thing. That means 75 and 75.0 mean the same thing. So you know already that 75% means 75 over 100. So that first step is not a problem. Now your 75 can be written as 75.0, and you still know that that's not a problem. But the problem now is, how do we turn that 75.0 over 100 to 0.75? Now let me show you something. You can move that decimal point because you're divided by 100. So cancel out this 40, you move out this decimal point to the left. One step. Cancel out the second 0, you move out the decimal point to the left again, second step. So your decimal point is now before the 7. So that's why we came here. You don't start your answer with 0.75. That's why we turned it to 0.75. Okay? You cannot start a decimal with a point. That's why we started with 0.75. That's essentially what happened here. Okay? I'm going to teach you all more as time progresses in the week. Now, 24.7%. Let's go. 24.7%. What do we do with this? 24.7, definitely over 100. Percentage means divided by 100. And you know, of course, definitely you're going to get 0.247. What do we mean you're going to get 0.247? Cancel out the first 0. Your decimal point moves here. One step. Cancel out the second 0. Your decimal point moves here. Second step. So your decimal point is before the 2. Hence 0.247. So let's move on. Next question. 8%. 8 over 100, definitely. 8.0 over 100. 0.0. What happened here? Let's see. First step cancels out this 0. And the second step cancels out this 0. But the thing is, this is empty. You have to put 0 there. So your decimal point is before the 0 that you added. So 0.08. 0.08 is actually 0.08. Exactly. Okay. Wow. It's taking quite a while. Let's move on. Expressing decimals as percentages, I believe this is the final stage of our lesson today. So let's say 0.45. What does it mean? 0.45 is same thing as 0. When you're taking decimals percentages, you just need to multiply by 100. Just need to multiply by 100. How did we get 45%? When you multiply by 100, you know when we're dividing by 100, we move to the left. So multiply by 100, you move to the right. First step, cancel out 1 0. Second steps, cancel out second 0. So 45%. Your decimal point has disappeared to the end. Whenever your decimal point ends a number, of course, you can throw it away. So let's move on. 0.7, 0.7, yeah, times 100, 70%. What happened here again? First step, cancel out a 0. Second step, cancel out another 0, but this is empty. You have to put a 0 there. Hence, 0.7 turns to 70 point. And 70 points is the same thing as 70%. The decimal point will disappear. Let's